Hey, hey. All right, in case you missed the notes over the quadratic formula, here they are for us today. All right, so in this first example, I am just going to do my regular solving by factoring. I'm going to do this the shorter method that I've shown you guys before. So first I need to subtract this 15 to both sides. So I'm going to do that. So I get plus 2x minus 15 equals 0. So don't forget these things have to be set equal to 0 before we can solve them. Excuse me. So next, I need to find my factors. So 1 times negative 15, that's negative 15, and then my middle term is 2. Now remember, these are the easy ones. So whenever my leading term is 1, I can just go straight to this and figure out what my factors, or what the missing numbers will be. Because here it has to be x times x in order to get me the 1x squared there. So I'm going to go look at my factors, 1 times 15 and 3 times 5. So which of these is going to somehow add a 2? And yes, that's going to be the 3 and the 5. It needs to be a negative 3 and a positive 5. Negative 3 plus 5 adds to positive 2, and they multiply to negative 15. So we'll get x minus 3, x plus 5. And now I set both of my factors equal to 0, and I solve. So here I would add 3 to both sides. Here I would subtract 5 to both sides. So I end up getting x is equal to positive 3 and negative 5. And so there's my final answers on those. You can also do the factor by grouping if you would like, but for these purposes I just wanted to get through that one kind of quick. So we can see how we can factor this and get the answers 3 and negative 5. So now we're being introduced to this thing called the quadratic formula. Now the quadratic formula is, let's say, like, okay, we have one method of factoring, the one that I just showed you, the easy method for those easier the easier equations. And then we have our factor by grouping if that doesn't work. And if that doesn't work, we can resort to this last one we call the quadratic formula. We can use this for every single one of them. This works without fault every single time for any of these quadratic equations. So he's always a safe bet. It looks scary, but it's really not that bad. All it is plugging 3 numbers into a formula. So you can see it here in front of us. We call this thing standard form. So we have the ax squared plus bx plus c equals 0, and that's the standard form of our quadratic equations. So then our formula that we use is right here. And I'm going to sing you the little song in case you missed it in class. This is a song that one of my math teachers taught me, and I've never forgot it. So here we go. Don't laugh too much. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So rewind and listen to that song again. Try to sing it in your head with me. But that's a little song that'll help you remember the formula. All right, so let's slide down here to this next example, number 2, and practice this one together. All right, so my a value is right here. We're just working with the leading coefficients, or the coefficients in front of our variables here. So in this case, there's a 1, so my a is 1. My b is going to be 2, and then my c is negative 15. And now I'm just going to take these 3 things and plug them into my formula. So here's the little song again. X equals, now in the song we say negative b, in the formula it shows negative b, but what that really means is the opposite of whatever b it is that you have. So in this case our b is a positive 2, so we would take the opposite of that. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so right now you're probably looking at this and you're like, that looks horrible, but it's really not that bad, because our calculator is going to end up doing most of the work for us. All right, so if I pull up my handy dandy calculator right here, all I'm going to do, what I want to do first is simplify the stuff inside my square root sign. So I'm going to plug everything in exactly how I wrote it. So I have 2 squared, parentheses are so important during this time, times 1 times negative 15. And I hit enter, and I see it's 64, okay? So x is equal to negative 2 plus or minus the square root of 64. Again, all we did was plug all of this stuff in here to simplify it to 64 here. And then all over 2 times 1 is 2. Hopefully you're thinking, yay, 64, that's a perfect square, right? So now I can further reduce this guy. I'm going to take the party over here. So now I'm looking at what is the square root of 64? Hopefully you're saying it's 8. Yes, so I have x is equal to negative 2 plus or minus 8 divided by 2. And I kind of forgot to mention this earlier, but in case you're wondering why there's this plus and minus sign, if you remember the conversation we had about square roots, for example, the square root of 64. So square root of 64 is 8, because 8 times 8 is 64. However, it can also be negative 8, right? Negative 8 times negative 8 is also positive 64. So that's why we use this little plus and minus thing out in front, because it can be positive 8 and it can be negative 8. So that's where we get this. So now in this step, what I can do here is break this apart into two separate equations. Because remember with these quadratics, we're always going to be getting two answers for these. So I'm going to break those apart. So I'll have x is equal to negative 2 plus 8 divided by 2. And then I also have x is equal to negative 2 minus 8 divided by 2. And then from there, it's just a simple little fraction I can solve. Negative 2 plus 8 is 6, and then 6 divided by 2 is 3. And then over here, negative 2 minus 8, that's negative 10. Negative 10 divided by 2, that's negative 5. Okay, so I get my two answers, and right below here it says, how do your answers to problems 1 and 2 compare? Well, if you look back up at the top at the very first example that we did, where we did a different way of factoring, we got the same answers, right? So just wanting to show you guys that you can work all of these things in these different methods, including using our quadratic formula, and you'll still end up getting the same answer. All right, so now here we are, example number 3, and let me just show you why sometimes we can't do the quadratic formula. So, I'm sorry, our regular factor by grouping. So if I do my regular factor by grouping, negative 2 times 3, well, that's negative 6, and then my middle term is negative 4. Write out my factors of 6, and these are them. So there's no way I can ever get 1 and 6 to add to negative 4, right? Even if I did like negative 1 and positive 6, or positive 1 and negative 6, neither of those will get to negative 4. And the same will happen here for the 2 and 3. If I do negative 2 plus 3, or even negative 2 minus 3, or any of that, those are always going to, they're not ever going to end up equaling negative 4, which is why we have to use the quadratic formula in this example, okay? All right, so let's go ahead and fill out our stuff. So A is now negative 2, B is negative 4. Don't forget to include their signs. And then C is positive 3. So here we go. X equals, and remember the negative b, you can think of opposite b, and the reason why is this, that would be negative b, so negative of negative 4, well that's like negative 1 times negative 4, which is positive 4. Alright, so again, whenever it says negative b, think opposite b. So x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and so now we got our formula. I know it looks terrifying, but my calculator is going to handle some of the heavy loading for me. So I'm going to plug my stuff in exactly how I wrote it. So negative 4 squared minus 4 times negative 2 times 3. Alright, and I get 40. So this is saying x is equal to 4 plus or minus the square root of 40 divided by 2 times negative 2 is negative 4. All right, now remember when we learned how to simplify radicals? Now hopefully you're seeing when that's going to apply for us. So right here I have the square root of 40 and I want to simplify that. So I'm going to do that right here kind of off to the side. Square root of 40, what is the largest perfect square that fits into 40? And that is 4. So I have the square root of 4 times the square root of 10, but we know that the square root of 4 is 2, so I'm left with 2 times the square root of 10. Yes. 2 times the square root of 10. All right, so now I'm going to replace this with the square root of 40, and I'm going to do that back over here. So here we go, back over here. So now I'm left with x is equal to 4 plus or minus 2 times the square root of 10 divided by negative 4. And that's a pretty ugly answer, but we can still reduce him a little bit further. If you can get here to this step, then I'm so proud of you. That's awesome, and you did a really great job. But we want to take it a step further and reduce these things. So really what these are kind of like fractions. So if I kind of ignore this for a second, I have 4 divided by negative 4. And then I also have this 2 root 10 divided by negative 4. So I want to simplify those things. And we're going to simplify these in a special way by finding what their greatest common factor is. So we're going to ignore kind of for a second this radical 10. He's in his own little world and we're not going to deal with him. Only our whole numbers will play together. So what's the greatest number that can divide into a 4, a 2, and a negative 4? And the answer there is a 2. So I'm going to reduce all of these things by a factor of 2. So first, this 4 divided by 2, that's 2, plus or minus. 2 divided by 2 is 1, and then the square root of 10 is just left there. And then negative 4 divided by 2 is negative 2. In the future, you're going to learn that it's not usually okay to have a negative in your denominator like this, but for now he's going to be just fine, and this would be your final answer. So whenever you have radicals included in your answer, you can stop and leave it like this, and you're good. But if it's like the previous example that we did where we get a perfect square in this step, and we can simplify our perfect square to a whole number, then we'll go ahead and finish writing out those answers. You could write these out also if you wanted to. You could say x is equal to 2 plus 1 times the square root of 10 is the same as just the square root of 10 divided by negative 2, or x is equal to 2 minus 1 square root of 10 divided by negative 2. Alrighty. So again, either of these answers would be totally fine for me. Okay. Perfect. So let's go ahead and move down to example number 4. All right, so example number 4, I have a is equal to 2, b is equal to 3, and c is equal to negative 2. Okay, so now I'm going to plug these things in. I have x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, get your calculators going, and now I have 3 squared minus 4 times 2 times negative 2. And I get 25. So now I'm left with x is equal to negative 3 plus or minus the square root of 25 divided by 4. And is 25 a perfect square? Yes! Yes, he is. So x is equal to negative 3 plus or minus 5, right? The square root of 25 is 5 divided by 4. And now this is the step. Since I can do whole numbers, I can add these whole numbers and subtract them. So we're going to go ahead and break this apart into our two separate answers and see what we get. So now I'm going to have x is equal to negative 3 plus 5 divided by 4, and x is equal to negative 3 minus 5 divided by 4. Okay, so here, negative 3 plus 5, that's 2. 2 divided by 4, that would reduce to 1/2, right? 2 divided by 4 is equal to 1/2. And then right up here, negative 3 minus 5, that's negative 8. negative 8 divided by 4, that is negative 2. Sorry. And x equals negative 2. All right. And so there we get our final answers. And again, you can always take these just like with our regular factoring. You can always take these guys and plug them back in for your original equation and for x, and make sure that it checks out and does equal to 0. In this last example, looking at number 5, okay. We have a is equal to 6, b is equal to negative 3, and c is 7. So here we go. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's go ahead and simplify what we can. Get our calculator. Now I have negative 3 squared minus 4 times 6 times 7. And I get negative 159. Okay, so let's jump back over here. So that means I have 3 plus or minus the square root of negative 159 divided by 2 times 6 is 12. Okay, so you might be thinking, what? Negative 159? That's crazy. We haven't done anything like that. And you're right, we haven't. And actually, truth be told, this is technically impossible to do. You can't actually take the square root of a negative number. Stop and think about that for a second. For example, if we have like the square root of 25, yes, that can equal positive 5, and it can also equal negative 5, right? Because positive 5 times positive 5 is positive 25. And negative 5 times negative 5 is also positive. So there's no number that when I multiply it by itself, that will give me a negative number, right? Because if I'm multiplying something by itself, a positive times a positive is a positive, and even a negative times a negative is a positive. So you'll learn more about these in Algebra 2. And just a little side note, what you'll learn about is what we call the imaginary units, or this little I, okay? We call that imaginary numbers, and you'll learn more about that later. So for our purposes, if you get down to something like this, go ahead and just stop there, and we'll say that this is unsolvable, or we can't find a solution for this. Not, at least not now in Algebra 1, but you will one day, 2 years from now, in Algebra 2. Alrighty, so if you have any questions over any of these parts, please come see me in tutorials. If you didn't get the notes, I have this whole note sheet available for you too. So yeah, holler at your girl if you need anything. Thank you.